Let's take a look at the unit 1.5 to 1.6 pretest. We're going to run through this pretty fast, but this video is going to be pretty long, so I again would recommend that you don't just go through and watch the video completely and just copy down the answers. I would recommend that you go through, do the problems, come back to the video, and then check out the video to use it as more of an answer key. If you get stuck on something, you don't know how to do something, then come back and watch it. So we start with number one, finding the period. The period of sine is 2 pi, so we're going to go 2 pi on top, and then we're going to divide it by the number in front of the x. That's 4, so I want to reduce this. If you do not reduce it, I won't give you full credit. So we get 1 pi over 2, or just pi over 2. Part B, this is a cotangent. Cotangent has a period of pi, and so I'm going to divide that by the number in front of the x, which is a 1/5. When I flip that over, I get 5 pi. Secant has a period of 2 pi, so I'm taking 2 pi divided by pi. Secant is the reciprocal of cosine, so then the pi's cancel out, and I just get 2. And lastly, here's a cosine, that's 2 pi divided by the number in front of the x is a 1. I can just leave it like that, I don't have to do anything else with it. Here's the way that this test is going to look. I want you to be able to do each different part of this. So, well, we're going to find the amplitude, period, horizontal shift, and vertical shift. And the first thing we're doing is we're just going to name them. So the amplitude in part A is the number in front here. Let me take a second and get the smartboard on so that my circle is actually on here. That should be better. So an amplitude is the number in front. The A value, so the amplitude of this is 3, absolute value of 3 technically, but absolute value of positive 3 is just 3, so no issues there. The period is 2 pi in sine, and we're going to divide by that by the number in front of the x, which is just over 1. Horizontal shift is the number that is added inside the parentheses, and there isn't any. The vertical shift is the number that's added on the outside. There isn't any there either. Part B, amplitude is absolute value of -2, which is 2. The period is 2 pi divided by 4, which is pi divided by 2. The horizontal shift, there's nothing added or subtracted on the inside. Vertical shift, nothing added or subtracted on the outside. You will get points for this horizontal and vertical shift saying that there isn't any. If you put there is none, or empty set, or doesn't exist, or nothing happens, or 0, I guess, would be fine in these situations too. The amplitude, for the next one, this cosine graph, the amplitude, the number in front of the cosine, is a 1. The period is 2 pi divided by 1/3. The horizontal shift, there's nothing added inside with the cosine, but there is a +4 on the outside, so the vertical shift is up 4, and you need to actually name where that's going. Don't just put +4. You need to tell me that it's actually going up 4. Amplitude in this one, absolute value of -2.5 is 2.5. The period is 2 pi divided by the number in front of the x, which is a 3. The horizontal shift is actually going to be a starting or ending point on this problem, so don't just put -6. You need to put 3x minus 6 and set it equal to 0. That's going to find the horizontal shift. I add 6 to both sides, divide by 2, divide by 3, and I get a 2. And so I get my horizontal shift is that I start at x equals 2. And so I'm going right 2. So if you put x equals 2 and showed me the work, or you just put that I'm actually going right 2, that would be fine as well. We're not going right 6. We have to account for that number in front of the x. So you would need to truncate that first, divide everything by 3, and then that would go, say that I have -2, which is right 2. A vertical shift has a -4 on the outside. So this is going to go down 4. The last part of this test is just sketching the graphs. So again, I'm doing all of the same stuff. I find the amplitude, I find the period, the horizontal shift, which isn't there, vertical shift, which isn't there. And so now I need to sketch this. So it goes up 3, and down 3. Goes out to pi. I've got my midpoints here. Starts at 0. It's a sine graph, so it starts at the bottom, goes up to the top of the amplitude, comes back, goes to the bottom of the amplitude, comes back. And I'm fine with you drawing in one period of this graph. But enough information needs to be shown that I can identify the period and the amplitude. And don't just write it on the top, it needs to be written in the graph as well. So I should be able to look at the top part and see it. I should also be able to look at the bottom graph and see it. So the amplitude is absolute value of -1 in the cosine graph here, and for part B, the period is 2 pi divided by 1/4, which is 8 pi. The horizontal shift, there isn't one. Vertical shift, there isn't one. So this goes up 1 and down 1. Because it's a cosine graph, it's actually starts at the top of its amplitude, but I put the negative in front, so it flips it upside down. It goes out to 8 pi, so it ends there as well, halfway in between. And you can figure out, you can put as much of information in here as you wanted to show all of these points, but I need the ending point so that I can see the period and all the other hash marks in between, but you don't necessarily need to fill those in. So a cosine graph is now going to go up first because it flipped upside down, so it goes up first, up to the top, then starts going back down. Do not draw this arrow to go past the amplitude. I will take points off if you draw it to go past the amplitude. It only goes to -1 and then it starts coming back up again. Part C here. So I've got a sine graph with an amplitude of 2, a period of 2 pi divided by 2, or pi, a horizontal shift that wasn't there, and a vertical shift of up 1. So I'm going to do the vertical shift first. So I've got this graph going here. This is now my new x-axis. I've got an amplitude of 2, so I'm actually going to go 2 up from that and 2 down from that. And those are my new top and bottom of this graph. It's a sine graph. It has a period of pi. So I'm filling all my places here. The sine graph starts at the origin, but I took that origin point and moved it up 1, and so my sine graph is going to start here, which means that it's also going to end there. Goes up to the top of its amplitude, comes back down to the axis, goes down to the bottom of its amplitude. That's not the bottom. Here's the bottom. And then goes back up again. And so there's the sine graph with some vertical shift and a little bit bigger amplitude than we had before. Part D, we have a cosine graph. The amplitude is absolute value of -3, which is 3. The period is 2 pi divided by 1. The horizontal shift, I have one in this one. The vertical shift, I don't. So again, the easiest way, I think, is to find a starting point and an ending point. The starting point, I'm going to set this equal to 0, and I'm going to add pi over 2 to both sides. So I start at x equals pi over 2. Then I'm going to do an ending point. It's this equal to 2 pi, because I want to find out where am I moving that 2 pi, that ending point. I add pi over 2 to both sides. Get a common denominator here, so that's 4 pi over 2, which means that I actually end at 5 pi over 2. So I have a starting point. Let's plug the stuff in. So amplitude of 3, 1, 2, 3, 1, 2, 3. It didn't go up and down at all, so I don't have to worry about that. My horizontal shift is going to start at pi over 2. And it's going to end over here at 5 pi over 2. I've got all the numbers in between here. And again, you can figure them out. You can find them out by doing some adding and subtracting, dividing type things. If I wanted this middle point, I would take the pi over 2 plus 5 pi over 2, which is 6 pi over 2, which is 3 pi. Divide that by 2, and I get 3 pi over 2. So I can find that. I don't necessarily need to, but you could if you wanted to. This is a cosine. It's going to start at the bottom of its amplitude because I flipped it over. So at the pi over 2, which was the shift over, at the bottom of its amplitude is where it starts, goes up at the top of its amplitude, comes back down, and again it curves at the end. Do not draw it as a straight line at the end. It has to come back up after it hits the bottom of its amplitude. And so there's the graph for the cosine there. Number 4 talks about tangent, cosecant, cotangent, and secant. So I want to, again, go through and do these things. In tangent, the things that I need are the period and the asymptotes. So the period is going to be just pi divided by the number in front of the x, which is 1/3. So the period is going to be at 3 pi. I don't know why I put 6. I was still thinking cosine, I bet. So I get 3 pi. The asymptotes are going to be at places that the original asymptotes after I changed this period. So the original asymptotes for tangent were at negative pi over 2 and pi over 2. So I'm going to take this tangent part here, x divided by 3. I'm going to set it equal to pi over 2, negative pi over 2, and I'm going to set it equal to plane pi over 2. Those are going to give me the places that my asymptotes are happening. So I'm going to multiply by 3 on both sides, and so I get an asymptote at x equals negative 3 pi over 2. And times 3 times 3, I get an asymptote at 3 pi over 2. And as I'm scrunching this in between these numbers here, I remember that I told someone that I was going to change the pen style here so that it was a little bit easier to read. And so now hopefully that will happen. Let me just redo this part here, so that that's a little bit easier to read. So I was taking the x divided by 3, set it equal to negative pi over 2, multiplying by 3, and for some reason that didn't actually make that change. Let's see if that helps. So I multiply by 3, and those cancel, and I get x is equal to negative 3 pi over 2. Hopefully that helps for you to be able to see this. Then I'm going to take the x divided by 3 and set it equal to pi over 2. Multiply by 3, and I get that 3 pi over 2 is going to be my other asymptote. So the tangent graph goes around the origin here. I've got one at negative 3 pi over 2 as an asymptote. And I've got one here at 3 pi over 2. My tangent graph goes in between here. And that's really all I need in order to have a good sketch of this. I don't need all the rest of the information. I have a period of 3 pi from negative 3 pi over 2 to 3 pi over 2. That is a distance of 3 pi. And so I don't really need anything else in terms of this tangent graph. Cosecant graph for part B. So when I have cosecants, the first thing that I want to decide on is what type of graph I'm making, and I'm going to be making a sine graph. And then I want to find all of the parts of the sine graph that I would have to usually find. Absolute value of negative 2. Just switch colors on me. Even though my my blue light is lighted up. My blue light is on. Absolute value of negative 2 is 2. I have a red pen. So the period, I need the period here. Period in sine is 2 pi divided by the number in front of the x, which the pi's cancel out then, and I just get 2. Any horizontal shift, there isn't any. Any vertical shift, there isn't any. And so it's not too difficult of a sine graph here. We've got an amplitude of 2, so we go down 2 and up 2. A period of 2, so this goes out to 2, halfway in between 0 and 2 is 1. My sine graph is going to start at the origin. It's going to go down because I've got a negative in front of this, so it's going to go down to the bottom of its amplitude, come on back up, go all the way up, and come back down. So now this is a graph that I'm going to draw in dashed because it doesn't really help me do much in terms of answering the question, except that it allows me to find places where I have asymptotes. So let's try this blue pen again. There we go. Allows me to have places of asymptotes, and it allows me to draw in the graph of the cosecant. In green is what the graph of the cosecant actually is. So I need the sine graph to help me find the cosecant graph. But in terms of the sine graph actually being part of the graph, it's really not. Okay, so that's why I want to draw it in with the dashed portion there. We're almost done. So to take a look here at C, we've got a cotangent graph. And so with cotangent, the things that I want to find are the period, which is 1 pi divided by the number in front, which is 2. So that's actually at pi over 2. And then I want to go and I want to find, and I'll do it underneath here since I have some space, I want to find the asymptotes. The asymptotes for a cotangent graph are usually at 0 and pi, and so I'm going to take the b part, the 2x, and set that equal to 2x and set that equal to 0 to find my first one, and I'm going to take it and set it equal to pi to find my second one. Well, again, if you think about cotangent, as long as you haven't shifted it anywhere, as long as I haven't moved it left or right, it should be at 0, and it should be at the end of the period. Well, let's check to make sure that that works out. X equal to 0 is my first asymptote. And divide by 2, x equals pi over 2. Pi over 2 is my second asymptote. It's at 0 and at the end of my period here. So I've got the 0 point there. I have a negative in front of this cotangent. When I put that negative in front of the cotangent, usually it goes up to the left and down to the right. But now because I put that negative in front of there, it's going to go up to the right and down to the left. And that's enough for me to know that you know how to do this. But if you wanted to put make the graph look a little bit better in terms of a nice cooler trig graph, you can go ahead and put another one in there, and that would be fine too. Last one, part D. So I've got secant, so I need to know that this is actually going to be a cosine graph. So in the cosine graph, I'm going to find the period, which is 2 pi divided by 2, which is just pi. I'm going to find the amplitude, which is 1. I'm going to find a horizontal shift, which isn't there, and I'm going to find a vertical shift, which actually is a 1. Again, my blue pen turns into red. I don't know how that happens. So we'll try to get back to blue here. I've got an amplitude equal to 1, a vertical shift of up 1, so this goes up 1. And from there, my amplitude goes up 1 and down 1. A cosine graph with a period of pi starts at the top, comes down to the x-axis, which we moved up 1, comes down to the bottom of the amplitude, comes back up, and then comes back up again. These are things that we're going to draw in, not exactly fitting or with a dotted line, because I don't want the cosine graph. What I actually want is the secant graph. So the places that this equals 0 or crosses the x-axis are here. Remember that I moved that x-axis up 1, and so it ends up kind of looking like it actually isn't crossing the x-axis, but it is crossing that new line that we made for the x-axis. And then I actually want to draw in the secant graph. The secant graph in this case looks like this. This is actually going to go like here, but in order to do that, I would need another asymptote here. Whoops. At the end. So if you want to draw in a few extra parts, that would be fine too. There's the secant. That's the whole graphing test. Take some time. You have to do the graphing. Do not just watch this video. You have to try the graphing in order to make sure that it makes sense to you.